Good morning. We will start a new chapter, Introduction to Graph, Session 1. So the chapter itself tells you that. That means we have to do all the sessions or whatever we write in the graph book. So basically there is nothing much introduction in this chapter because we have already completed in data handling about what is a bar graph, a pie graph or a sector graph or a circle graph, what we call, and a histogram, right? We have already discussed what are these type of graphs and how do we plot them. The only thing what we have to learn in this is about something called as a linear graph, or we call that also as another word or a different form known as a line graph. So what is a line graph? See, linear graph, when I talk about, it only comes in the form of a straight line, but it is a graph joined by the points, right? A line graph, when we talk about, a line graph displays data that changes continuously over a period of time. Now if I talk about the temperature in a given place, so how it could be? It could be like this if I am plotting something, right? So if I just join this, can this be the temperature? There is a slight rise, slight fall, right? Or when we talk about the share market, how is the market price going up and down? So can we give the data like this? So that is something related to a line graph where the given data changes continuously at equal intervals of time at a given period of time, over a period of time. That we call that as a line graph. So the next part what we learn, that is a linear graph in the second half. So first let's understand about the line graph and quickly we move to the exercise, children. What you can do is give the heading Introduction to Graph. You need not give any introduction for these three because we have already understood and written about them in the data handling chapter. You directly write a side heading as a line graph and give the definition and we will start. Quite a few number of exercise. First one, the few sums are which are to be done in the text, which are already graph is given in the book and we have to only write the theory. So it's up to you when the theory part is there where you want to write. So when the plotting part comes, we can do that in the graph book. We'll start with the first exercise. The following graph shows the temperature of a patient in a hospital recorded every hour. So I hope you can see the graph what is given here. What was the patient's temperature at 1 p.m.? So I will just draw here because if I go on telling this orally, things will not be convenient. So this is 9, 10, 11, 12, 1, 2 and 3. This is AM. So this is noon and this is PM. It starts. Now see, the temperature difference, if I talk about here, it is just a 1 hour difference. That means this should be 8 AM or from 0 or whatever it has to start. We know that we always do that by a jag line or a quint line. So what about that, what they have given here? They have given temperature. Now temperature part also it's in the same part where the jag line comes because it starts from 34, 35, 36, 37, 38 and 39. So I will just randomly draw some points here. The next point is at 36. The next point 11 will come at 39. Then we have 12 at 38 and 9. So let me first join this, right? Then we have 1 at 36 and 37, 36 and 37 here. Then we have 2 at the same point again. This is 1, right? Okay, 2 at the same point. Then 3 we have at 37. Okay, so easy for me to tell and even for you to refer here. What was the patient's temperature at 1 p.m.? So at 1 p.m., what was the patient's temperature? So at 1 p.m., the patient's temperature was 36.5. It is between this. Direct answer, children. What you have to answer this. Question number 1, A part, what you will copy it. What was the patient temperature at 1 p.m.? Just put a hyphen and write it was 36.5 degrees Celsius. B part. When was the patient temperature 38.5? So 38.5, the patient's temperature was exactly at 38.5. This point, right? At 12 noon. At 12 noon, I think I missed it. Yeah, it's here. 38.5. So this is at 12 noon. Next, C part. The patient's temperature was same. The patient's temperature was the same 2 times a day given during a given period. What were these 2 times? At what time the patient's temperature was same? It was same at 1 p.m. and 2 p.m. The temperature was same. That was how much? At 1 p.m. and 2 p.m. it was 36.5. They are not asked how much. Then, what was the temperature at 1:30 p.m.? So 1:30 p.m. the temperature was 36.5, right? D. 36.5 degrees Celsius. During which period did the patient's temperature showed an upward trend? Now, during which period did the patient's temperature show an upward trend here? Upward trend means this part. This is the portion where it showed an upward trend, right? During that period. So, which period it is? During 10 a.m. to 11 a.m. That was a period. During 10 a.m. to 11 a.m. the patient's temperature showed an upward trend. That is what you can write. So, next one. Quite a simple, children, here. Now, the following line graph shows the yearly sales figures for the manufacturing company. So, again, finish this. We'll go with the next one. Almost all the sums are similar here. What you have to read the graph and you have to analyze the given. So, let's check the textbook itself for the graph here. What were the sales in 2002? Easily see, years are given in the x-axis and sales representing is given in the y-axis. You can read it from the graph here. So in the year 2002, what was the sale? The sale is in terms of rupees, that is in terms of crores. So in the 2002, the sale was 4 crores. Next, A part it is. B part. What were the sales? Okay, here we have one more question. So A part, first one is 4 crores. What was the sale in 2006? It was 8 crores. B part, what were the sale in 2003? 2003 it is 7 crores. Second part, what was the sale in 2005? It is 10 crores. Very simple, children. C part. Compute the difference between the sales in 2002 and 2006. Difference in sale. So, in 2002, what was the sale, children? Let us first write. The sale was 4 crores. And in 2006, the sale was how much? The sale was 8 crores. Difference in sale. 8 crore minus 4 crore is equal to 4 crores. Clear? Next. In which year was there a greatest difference between the sales as compared to the previous year? Now, what you have to do for this is, look at the question. In which year there was the greatest difference between the sales as compared towards the previous year? Now, we have to go on seeing the difference in sales. For example, difference in sales, let us find for all. Difference in sale. So, 2003 minus 2002. I will write here in terms of year. So 2003 children, it is 7 crores minus 2002, it is 4 crores. Right? So 3 crores. The difference in sale. Let us first find out the sale in every year. Then let us find which difference was the more. Next, this was the first one. Next time we find 2004 difference and 2003 is what is the difference. Let me find. So 2004 the sale was 6 crore minus 2003 the sale was 7. Oh, once again 2004 what I have to see 6 crores and 2003 it is 7 crores. So difference in sale, don't write that in terms of minus, write it as it is 1 crore. We know that the amount will come like that, but still as in terms of an amount we'll just write it as a number only here, remember. So check with the previous year now, 2005 and 2004. So 2005 it was 10 crore minus 2004 was 6 crore. Difference is 4 crores. Last one is again 2006 in 2005. See, we have to actually find a difference where there is a rise, not where there is a low. So 2006 sale is 8 crores minus 2005 sale is 10 crores. So this is 2 crores here. So this and this we are actually not supposed to consider because there is a rise in low in sale and rise in sale we are comparing. But what they have asked, in which year there was a greatest difference between the sale as compared to the previous year. So in the year 2005, give the conclusion. In the year 2005 to 2004, there was a greatest difference in the sale, that is 4 crores. That should be the conclusion. Very clear? Okay. Let's quickly go to the next one, third one. A very simple exercise it is. For an experiment in botany, two different plants, plant A and plant B, were grown under similar laboratory condition. Dotted lines they have given and one simple line what they have given. Their heights were measured at the end of each week for 3 weeks. The results are shown. So, weeks are given in terms of x-axis and height is given in terms of y-axis. How high was the plant after 2 weeks? Second part is 3 weeks. How high was the plant after 2 weeks? Just check here. In the graph when you check, so the point what we see, how high was the plant after 2 weeks? Both the plants, when we consider the point, simple children, after 2 weeks, at point 2 you check, where is the point highlighting? It is highlighting at 7. So it was at what height? It was after 2 weeks, it was at 7. What have they given here in terms of centimeter? After 3 weeks you check where the point comes. After 3 weeks, which plant are they talking about here? About plant A they are talking. But in that first condition, both are coming at 7th only, right? Now here in plant A, what you have to find here is, plant A is the dotted lines. This is plant A and this is plant B. Look at plant A, where it has come. It has come in terms of 9. It has grown 9 centimeter after 3 weeks. Next question. How high was plant after 2 weeks and 3 weeks? Same thing. B part. So this was for plant A. Now this is for plant B. For 2 weeks, again same children, because it was at the same point, 7 centimeter. What was next one? 3 weeks. Let us see, where is it at 3 weeks here? Plant B, it is at 10 centimeter. C part. How much did plant A grow during the third week? This was about plant A in third week. How much did the plant A grow during the third week? Now when we have to talk about during the third week, how much did the plant A grow? With respect to what we consider is, with respect to the previous week consider. That is nothing but 9 minus 7, that is equal to, it grew 2 centimeter. Of course, when I talk about some comparison, how tall I am, I always compare it with my next person who is there with me, right? So just see previous part, third week, how much did the plant A grow, what they are asking, right? So third week the growth is 9. What is in the second week? It is 7. So from second week if I check, it is 2 centimeter growth. How much did the plant B grow? D part, plant B. How much did the plant B grow from the end of second week to the end of third week? Actually, they had to ask the question similarly. The previous one also, which they haven't. So this is 10 centimeter was there at the third week, 7 centimeter at the previous week, 3 centimeter it grew, plant B. During which week did the plant A grow the most? What do you think? Plant A grew the most in which week here? Now see here, when you see the growth of plant A dotted one, it started little bit, then it actually went on top, right? In the second week, after first week, which comes as a second week, what we can tell. Or best you can tell is here, after first week, simple, at the second week you can just tell here. During which week did the plant A grow the most? Now see, answer becomes a bit hypothetical here. You can also write after first week, nearing to second week can be the answer. Am I right? Second week directly also can be the answer. Next part, during which week did the plant B grow the least? Now plant B is the dotted line part. So during the first week, were the two plants of the same height during any week shown here specified? So E, F, G part, right? Yes. At the end of second week, both the plant grew to a particular height only here, that is 7 centimeter, what we had checked. So both the plants grew the same. So at the end of second week, both the plant A and plant B grew at the same height. Right, children? So the next one, that is fourth one, what we have, it is again similar to the question what we have just done. They have given us two graphs where we have to check the temperature scale. Mark fourth one for homework. Okay, let's quickly move to the fifth one. Fifth one is something where we have to draw the linear graph. Let us start with that. Now the linear graph, when it comes, you have to do that in the graph book. Use the tables given below to draw the linear graphs. That is a line graph instead, nothing what you can say here. Number of days, hillside city received a different part here. Population in thousands. So now it is up to you. You can either draw two different graphs or you can plot them in the same graph, right? No, I'm sorry. The first one has to be done. The second one, see here, they have given you two values. So we have to plot them in the same part. Let us first finish the first one. So always I will just have it draw it here, children. So your x-axis, number of days, that is always numbers will be in the y-axis. Number of days. This is year. Now we are starting from which year? 2003. So I'll have a jag line here. So 2003. After 2003 I have 2004. 2005, 2006. That's all. Numbers we have 8, 10, 5, 12. So shall I take this as 2, 4, 6, 8, 10, 12. Use the scale. What scale we have used? 1 unit is equal to 1 year. Completely 2003 to 2004 I have used. In y-axis, so this is x-axis. One unit is equal to, or 1 unit is equal to 2 centimeter. 2468 we have taken. So let us plot accordingly. In 2003 it was 8. Mark it here. In 2004 it was 10. In 2005 it was 5. 2005 it was 4 and 5, which comes here is here. In 2006 it is 12. So start. Right? This is how you draw the graph. Linear, but it is actually a line graph. Whenever we talk about a linear graph, see they have given draw linear graphs here. Linear is nothing but straight, but here the whole graph is not a straight line. This is a line graph basically. Linear graph, when we talk children, it actually comes like this way or this way. Anyhow, it's always joined by the straight lines, right? So let's go with the next one. Scale, I will keep it. Year, anyhow, it's given same thing. Oh, we have one more year extra. So the point what they have given is everything about 12. So it is again 12.1, 12.2, all about 12 it is. So instead of this line, we'll just take it 1, 2, 3, 4, 5, 6. It's easy for counting also further. One more point what you have here is 2006. So 1, 2, 3, 4, 5. I think it will not fit. Let me just change it. Scale, I will make this as 1 unit is equal to 1 centimeter. So I'll take this as 13, 12, 11, 10, 9, 8, 6, 5, 4, 3, 2, 1. 2003, 2004, 2005, 2006 and 2007. So this is x-axis and this is y-axis. So here you have what they have given, numbers, number of men and women, and here you have year. So both the data has to be plotted on the same graph, only line drawing can be different. So number of men in 2003, first we consider with respect to men. In 2003 is 12, then 2004 is 12.5, then we have still extra numbers children here. I didn't see. 14. Okay. We have then the next part is here. 2004 is here 12.5. 2005 is 13, 2006 is 13.2, 2007 is 13.5. Yes, points are actually going, but actually it is not a straight line. I have joined it, but children always remember that should be a straight. It should be always joined with the points. Mine is actually coming, but it is not a straight line. Small difference is what you get. Look at the next one. Number of women, 11.3. So I'll start from here. So this 11.3. The next is 11.9. Then next is 13. The next is 13.6. 13.6, which we did not have it here. Okay, the next is 12.8. 2007 is 12.8. We'll have this by dotted lines. Very clear? So dotted line represents number of women and the straight line what I have drawn represents number of men that you can write here. This is women and this is men. Very clear how to draw? The scale I have kept the same thing. Or simple. Right? First one is very clear, second one is also very clear how to draw. This is the only graph what we have here, children, in this exercise. Again, the next one what we have to read from the given data only. So, sixth one. I wrote this and we'll quickly finish last two sums for today's session, and then we are also done with the exercise. A courier person cycles from home to the neighboring suburban area to deliver a parcel to a merchant. His distance from town at different time is shown in the following graph. If you can see here, what is the scale taken for the time axis? Now, just look. One box represents 1 unit. How many boxes are taken? 1, 2, 3, 4 boxes are taken for time. So, what is the time scale taken here? Sixth one, A part. So, I can say 1 hour is equal to 4 units. Am I right? Each box is 1 unit. How much time did the person take to travel? So he traveled from what time to what time do you think? 8 a.m. to 11:30 a.m. Right? That means he took how many hours? 1 hour, 2 hours, 3.5 hours. That's the answer. How far is the place of the merchant from the town? So, how far is the place from the merchant to the town? Just see how many kilometers is going. 22 kilometers. The last part to travel. At 11:30 where he is traveling, you see 22 kilometers is traveling. Did the person stop on his way? Do you think there was a stagnant in the graph? Yes. At between 10 a.m. to what time it is? 10:30 a.m. The person stopped on his way. Explain. Because the graph shows a straight line. Because the graph shows straight parallel line, let us write. This graph, because straight line can be this also, children. The graph shows straight parallel line with respect to, WRT is with respect to x-axis. E. During which period did he write fast? Do you think which period he went very fast? From, see, the curve almost goes like this, right? But one curve goes very straight. That is between 8 a.m. to 9 a.m. he drove very fast. Sorry. This other graph goes very casually. And the last one now. Now, look at the 4 graphs what they have given. According to them, so this is time and this is temperature, right? One is this, second is this, third is this, and fourth is this. Okay, which according to you could be temperature graph? So this can be a temperature graph and this can be a temperature graph. This and this cannot be a temperature graph. Now see, with respect to time, if I consider, the temperature is increasing at equal intervals of time. Morning 10 a.m. this was temperature, afternoon 12 noon this was temperature, then 2 p.m., then 3, then 4, then 5. We can see there is a slight raise in temperature, right? Or there is a slight fall in temperature. Look at this. For example, if this is say around 8 a.m. No, this is 0 here. This is around 8 a.m., 9 a.m., 10 a.m. we are considering. Okay. 8, 9, 10. Time and temperature, let us consider from 0, 10, 20, 30, something like At 9 a.m. the temperature suddenly shooted up and it was constant. It went on increasing. That means at 9 a.m. initially temperature was 10 degrees Celsius, then 20, then 30, then 40, then 50. Can you imagine the temperature just shooting up at one time at 9 a.m. only? The temperature is just rising? No, right? It's not possible. Same as here. Can you just imagine? The temperature can be constant throughout. For example, it was 30 degrees Celsius at 9 a.m., 10 a.m., 11 a.m., 12 noon, 3, 4, 5. It was 30 degrees Celsius flat. Not possible, right? So only these two are possible. Can there be a temperature time graph as follows? Justify your answer. First one. I will just send you the thing what you have to write. I will discuss that orally, but the first one is possible because there can be an increase in temperature with respect to time. That is, at equal intervals of time, temperature can increase. At equal intervals of time, the temperature can fall down or decrease. The temperature cannot be, or what we can say, there can't be different temperature at fixed time. It can't be a same temperature at different time. Right? The same thing what I have discussed, I'll send you that what you have to write. So with this we complete the first exercise. What I can talk about is a line graph. The next part we will study about a linear graph.